So here when it comes to the number system, it will going to use a well-defined symbol that we call that as a digits. Whatever is there in the decimal point right side of that will be considered as what? Fractional part. The positional values are expressed in the power of 8. In hexadecimal number system, totally we are going to have, or it will going to consist of 16 digits. Hello everyone, welcome to the first session on chapter 3, that is data representation. I am Rohini TS, lecturer, Department of Computer Science, Vidhyaashram Pre-University College, Mysuru. So data representation here, chapter 3 in the first PUC's computer science syllabus. Then what about the marks weightage for this chapter? Totally you are going to get 8 marks from this chapter. So you are going to get one question from the 3 marks and one 5 marks question that you are going to get. Totally you will be getting 2 questions from this chapter and that is for totally 8 marks. So this is regarding the marks distribution of this chapter. Okay, so now in today's session we are going to learn about the introduction part of this chapter, how we are going to represent the data and which methodology we are going to use and what are the types of number system we have, everything that I am going to discuss. That is what? Number system, and along with I am going to discuss the types of number system in today's session. So let me get into the today's session now. So now you just understand, when it comes to the computer, we are going to use the computer mainly to get on our work. Then, how I'm going to give the instruction to the computer? So, whatever I'm speaking, can computer understand? It is big no. Why? Because computer understands only zeros and ones. So, whatever we are going to give the data and instruction to the computer in order to get on our work, we have to give the instruction and data that must be understood by the computer. That is what we call as binary language. Computer understands only zeros and ones. So, we are going to give the data and instruction in the human readable form. But when it reaches to the computer, it has to convert. Okay, so by making of that conversion, computer will going to understand that machine level language. Then it will going to process, then it will going to give the output or a resultant which must be understood by user. Okay, so this is what the scenario or a basic thing that you have to understand. Then how the data and instructions are to be stored in the computer system? So in the computer memory, whatever you are going to do with computer, any processing or some input and output, everything must be stored in the computer's memory, right? So then only computer will going to fetch the data and instruction, then it processes, then it will produce the required or resultant. Right? So, when it comes to the data and instruction, we are going to give, that means user will going to give the data and instruction that must be understood by the computers. So, that data can be either anything. So, I can call numbers, digits or any alphabets, characters, special characters, anything we can consider as a data. Okay, it can be image file, video, audio file, anything it could be. But when I'm working with that, when we are processing that, computer has to understand the data and instruction which is stored in the memory. It has to be converted into machine understandable form. That is what we call zeros and ones. So remember one thing, computer understands only zeros and ones. So whatever the data we are going to give, that must be converted into machine understandable form. So that is what the data representation, how we are going to represent the data. So data can be anything, but it has to be represented in the form of machine understandable form. Then only computer will going to understand and it will going to give the required resultant to the user. Okay, so here in order to make the computer understand that zeros and ones, we have a number system. Okay, so as we all know that computer understand only zeros and ones. Then how we are going to represent those numbers? For that we have a representation of a number, and what are the digits we have, how we are going to represent, everything comes under the number system. Okay, so here when it comes to the number system, it will going to use a well-defined symbol that we call that as a digits. So, in order to store the data and instruction in the machine understandable form, we are going to use the number system, right? So, then number system will going to be use well-defined symbols. So, that symbols are nothing but digits. So that is what regarding this number system, that is representation of a number in the well-defined symbol. So that symbols are nothing but digits. Okay. Then what are the categories we have in a number system? We have two types, that is positional number system and non-positional number system. So number systems are basically classified into two types. Okay, so what are the two types of number system we have? It can be non-positional number system and positional number system. This is what you have to understand, why we require the data to be represented and in which format we are going to represent the data. For that we are going to use number system, and it has two types, non-positional and positional. Okay, so when it comes to the non-positional number system, so you just recall the ancient days, how the people will do the calculation. They have used some sticks, stones and pebbles and all, right? So that is mainly for the calculation. So once they are done with the counting with their fingers, they have to use some other materials. So that can be either stones, pebbles or any of the sticks like that they have used. So that is mainly for the calculation purpose. So when it comes to the non-positional number system, here position does not specified. So that it will be called as what? Non-positional. So when it comes to the non-positional number system, very best example for the non-positional number system is Roman digits. So there we don't have the positions of a number. There we are going to use the symbols. Okay, so we'll see now. So in olden days, people will going to use this type of number system. That is what non-positional number systems were used in the ancient days or in the older days for the simple calculation. Mainly we are going to use the numbers for the calculation purpose only. Okay, for addition, subtraction, multiplication, division and all, we are going to use the number system. In non-positional number system, there is no weightage for the numbers. That is what we call that as a non-positional number system. And Roman number system is a very best example for the non-positional number system. Then, so this number system, when it comes to the Roman number system, how we are going to represent the digits or symbols? For example, what it represents? It is equal to 1, right? Then how we are going to write 5? This is equal to 5. So this is equal to 10. So here what we are doing, we are using the well-defined symbol. That symbols are called as what? Digits. Okay. But in non-positional number system, it doesn't have any weightage. So that is what it meant, non-positional number system. Roman number system comes under non-positional number system, and this is how we are going to represent the number. So this I represent 1 and this we represent 5 and this X represents 10. Okay, and in the same way we are going to use L, M like this. So this is for the representation, and we are going to use these symbols for the calculation. That is for the simple calculation, what addition, subtraction, multiplication and all we are going to use. But this is not so efficient or not so effective. So this number system cannot be used effectively to perform arithmetic operations. If it is just a simple calculation like addition and subtraction, then it will be fine. Then can we use this number system in order to make a complex operations like some of the arithmetic operation? Then it will be not so efficient. So we will come up with the next concept called positional number system. So positional number system, this has several types. So then what are the positional number system consist of? Here we have a decimal number system. So positional and non-positional. Positional in the sense it has weights, it has values, but when it comes to the non-positional number system, there is no weight for the numbers. So there we are going to use only symbols, that is comes under Roman number system. In positional number system, we have 4 types. That is what? Decimal number system, binary number system, octal number system, then hexadecimal number system. These are the 4 types which comes under positional number system. Okay, so first is what? Number system. In that we have 2 types. So non-positional number system and we have a positional number system. So in non-positional number system, Roman number system is an example for this non-positional number system. And in positional number system, we have decimal, octal, binary and we have hexadecimal. So these are the classification of the number system. Now we are going to understand each type of positional number system one by one. So in the positional number system, we have to understand one thing. So as I discussed earlier, number system is nothing but what? Representation of a well-defined symbol. That symbols are nothing but digits. So here we have a terminology called base or radix. Then what it means? The total number of digits present in any number system. So any number system in the sense it can be decimal, octal, binary or hexadecimal. That you have to remember. So the number of digits or total number of digits present in any number system, then we are going to call that as base or radix. Very, very important question for 1 marks. What is base or radix? So base or radix is nothing but total number of digits present in a particular type of number system. Okay, so I am going to explain each type of number systems, base or radix. But the total number of digits present in particular type of number system, then we are going to call that as a base or radix. That represents base or radix. So every number is represented by a base or radix. That is why we call this as a positional number system. We are going to represent each number with its base or radix value. Okay, so with x, which is represent x digit. For example, 2x. So if it is 2, 10. So this represents what? This is a base or a radix. This represents, this number system consists of 10 different symbols or 10 different digits. That is what it represents, the base or radix. For example, 101. If the base is 2, it is binary number system. I am going to make you understand each type of positional number system, but as of now you have to understand what is base or radix. It is a total numbers present in a particular type of number system. That is what it meant, base or radix. So now we'll see about this decimal number system. So what and all you have to understand in each type of positional number system? What is decimal number system, what is binary, what is octal and what is hexadecimal. In each type of number system, you have to understand what is the total number of digits present in it and what is the base or radix and what is the power of that number system and what are the subscript or a base radix that we are going to use for the each type of positional number system. That you have to be very clear. Okay, so when it comes to the decimal number system, it is most commonly used type of positional number system. Then this decimal number system totally consists of 10 digits. So decimal in the sense 10 digits. Then which are the 10 digits we are going to use? It is from 0 to 9. Okay, so it is combination of 0 to 9. Any number you are going to represent with a combination of 0 to 9, then we are going to call that as a decimal number system. Only when its base or radix is 10. That is what? It has 10 digits. So what is base or radix? The total number of digits present in a particular type of number system. So here we have a decimal number system, and how many numbers it has? It has 10 digits. That is from 0 to 9. Okay, and hence its base or radix is 10. So here you can see that. So represented by a base or radix. Every number is represented by its base or radix x, which represent the x digit. So if its base is 10, then that represents what? 10 digits. In the same way here, it has 10 digits, hence its base or radix is 10 itself. So these values or these digits can be used to represent any numeric value. That is what it meant, decimal number system. For example, 286. This is one number. Okay, so 286 is a one number, and I am going to give the base or radix as 10. I am going to give the base or radix as 10. That what it means? 286 is just a number, but if I represent this 286 with its base or radix as 10, then it is belongs to decimal number system. Okay, let me take one more example. 279 base 10. Okay, so if you forget to write this base or 10, you may lose the marks. Okay, don't forget to write its base or radix. Very important. When it comes to the data representation chapter, you have to use its base or radix for all the numbers. Okay, so 2, 8, 10. So what I told, when it comes to the decimal number system, it has totally 10 digits, that is from 0 to 9. Okay, so 2810, can I consider this as 28 and 10? Can we consider this as 28 and 10? No. Why? Because we have to take only the combination of 0 to 9. Okay, number can be anything, but it must be a combination of 0 to 9. In that situation, it will not going to be considered this as a 28 or as a 10. Instead of that, it will be considered as 2810, not 28 or 10. Okay, so why? Because the combination must be between 0 and 9. Apart from that, we cannot take any value which is greater than 9. It can be combination. So totally I can call this as what? 2810, and its base is 10 in the sense it is belong to this decimal number system. So here consider one decimal number. What is the number that I have taken? 542.76 base 10. So 542.76 which is base 10. So which can be represented in the equivalent value. How we are going to represent this decimal number in its equivalent value. Okay. So what is the first number I have? I have 5. So understand one thing. How we are going to represent any number system in its equivalent value? First we are going to take the digits which should be multiplied by the particular type of number system and which is raised to the power. Okay, so 542. So that is 5 into what is the total number of digits present in decimal number system? That is 10. Okay, so plus what is the next number? 4 into 10 plus then 2 into 10 plus then we have 7 into 10 plus we have 6 into 10. Okay. So now you understand one thing. Here we have two parts because I have decimal point here. Whatever is there in the decimal point right side of that, that will be considered as what? Fractional part. This is a whole number. 542.76 is a fractional part. So you have to give the weights now. Okay. So weight is nothing but which is the number first we have? That is 2. So 2 into 10 power 0 and here 4 into 10 power 1 and 5 into 10 power 2. So we are giving the weightage for that particular number system's position of the digits. So 2 into 10 power of 0. So understand one thing, any number with power 0 is always equal to 1. So this x can be any value. So it can be 2 power 0, 5 power 0, anything it could be. But any number with power 0 is always equal to 1. Then how to give the weightage to the number which is right side of that fraction? It must be minus. 7 into 10 power minus 1, 6 into 10 power minus 2. So now you understand one thing. This 5, 4, 2, 7, 6. These are the digits. These are the digits and this 10 power 2 and 10 power 1, 10 power 0, 10 power minus 1 and 10 power minus 2. These are the weights. So these are the digits and these are the weights. Now we have to find the value. So 5 into 10 power 2, 10 into 10, that becomes what? 100 plus 4 into 10 power 1. So 10 power 1 is 10 itself plus 2 into any number with power 0 is always 1. So plus, then how we are going to represent this minus? 7 into 10 power minus 1 is nothing but 1 by 10 plus 6 into 1 by 10 power 2. So it become what? Reverse. So 10 power 2 in the sense 100. So now we are going to find the value. So it become 500, then plus it become 40 plus 2 into 1 is 2, then 7 into 1 by 10 is 0.7 plus this become 0.06 and we are going to get 542.76 which is to the base 10. Okay, so this one line of code is very important in order to represent. So when it comes to the positional number system, we are going to give the position, that means its values, in which position it has, whether it is in the units, tens or hundreds or in the thousand. That is what the positional number system represent. So this is regarding what? Decimal number system. So next we have a binary number system. As I discussed, computer understands only binary values, that is 0 and 1. So when it comes to the binary number system, it is a machine understandable terms or a machine understandable language. So digital computers will going to be represents all the kinds of data and information in the binary system. So while giving the input, it must be in the human understandable form, but when it reaches to the computer, it must be converted into zeros and ones. Then only computer can process whatever the data and information is there. It has to be in the zeros and ones. So the binary number system consists of only 2 digits. So what is the base or radix then? It must be 2 itself, and it consists of zeros and ones. So 0 represents the low voltage. I can call that as off, and 1 represents the high voltage. We can call that as on. Okay. Then what is its base or radix value? That is 2, and it will be each digit or a bit. I can call this as a bit because 1 and zeros are the bits. So each digit or a bit in the binary number system can be either 0 or 1. Okay. The positional values are expressed in the power of 2. So when it comes to the decimal, we are going to express its positional value by 10. But in binary number system, we are going to represent its position value or its power, which is raised to 2. Okay. So now we'll see one number. So understand one thing. What are the examples that I can give for this binary number system? Can I write it 276 as a base 2? Can we take? No. Why? Because it has only 2 digits, that is zeros and 1. So that it can be 101 base 2, 00, make it as 1, 101, which is base 2. So only I can represent any number. When it comes to the binary, it has to be either 0 or 1. Okay. We'll see an example for this binary number representation. Okay. So consider a binary number that is 11011.10, which is base is 2. So that means what? It has only 2 different values, that is either 0 or 1. Then how we are going to represent it in equivalent value? That is this 1 into 2 power 4. So you have to give the power from here. Okay. 0, 1, 2, 3, 4. Okay. Don't give it in from the left to right. It has to be from right to left. Okay. So that 1 into 2 plus and 1 into 2 plus 0 into 2 plus 1 into 2 plus 1 into 2 plus then 1 into 2 plus then 0 into 2 plus. Okay. Don't we have any other number after that 0? So that how I am going to represent? I have to give the power from this position. 2 power 0 plus 2 power 1, 2 power 2, 2 power 3, 2 power 4. Then what must be the weights after the fractional part? When it comes to the right side, it has to be -1, -2, so on. Then we are going to get to know that its weights are, this is most significant bit, 2 power 4, 2 power 3, 2, 1, 0, -1, -2. And 2 into, so here we have what? 1. So 1 into 2 power 4. 1 into 2 power 4. 2 2 is a 4, 4 2 is a 8, 8 2 is a 16. So that is what we are going to get. And for this 2 power 3, 8. So 2 power 2, any number which is multiplied by 0 will going to be get 0 itself. So 1 into 2 will be 2. So then 1 into 2 power 0, that is 1. 1 1 is a 1. And 1 into 2 power -1, how we are going to write? 1 by 2 plus 1, 0 into 1 by 4. Then we are going to get 0.5 and 0.25 respectively. So this is how the representation of binary equivalent value will going to be happen. So now you consider one more example here. I have a binary number called 11010. Okay. So how I am going to represent? So we are going to make it as 1 into 2 plus 0 into 2 plus 1 into 2 plus 0 into 2. I have to give the weight from this side. So 2 power 0, 2 power 1, 2 power 2, 2 power 3 and 2 power 4. So here we have to understand one thing. The leftmost bit, which is the leftmost bit here, that is this one. Okay. So it has the high order bit. It has more weights. So here you can observe that which have more weight here, that is the last bit. That means which is the leftmost bit has a more weightage or a highest order bit. Then we are going to call that as a MSB, that is most significant bit. So which is as the most left side, that is what we call that as a most significant bit, and its weight is higher. So that we are going to call that as MSB. Very, very important question for the abbreviation, MSB and LSB. So LSB is the least significant bit, which has least lower bit, then we are going to call that as a least significant bit. So the rightmost bit, that is this one, will be called as LSB, and the leftmost bit will be called as MSB, most significant bit and least significant bit. So now we have a octal number system. This is one of the another type of positional number system. Decimal is 10 and binary is 2 and octal number is 8. Okay, so the octal number system has digits which starts from 0 to 7. It has totally 8 digits and it is 0 to 7. Then what is the base or radix of this number system? Then it is 0. And the positional values are expressed in the power of 8. So for decimal, it will be expressed in the power of 10. For binary, it will be expressed in the power of 2. For octal, it will be expressed in the power of 8. Okay, so any number which is lesser than or equal to 7, we are going to call that as octal number system. Okay, so tell me, let me take one example, 273, which is base 8. So here I have a digit which must be a combination between 0 to 7. So 273 I have taken and its base is 8. It could be on the example. So 1076, base 8, 8,972. Can we take this as an example for the octal number system? No, right? Why? Because I'm using a numbers called 8 and 9 which is not in the range, that it must be from 0 to 7. So that it cannot be expressed as the octal number system. It has to be within the 8 values. So you can take any of the values which can be a combination between 0 to 7. So here we'll see the representation of the octal number. Consider an octal number that is 234.56 base 8. Okay, how we are going to represent it then? 2 into 8 plus 3 into 8 plus 4 into 8 plus then 5 into 8 plus 6 into 8. How we are going to give the weights for each digit? It has to be from right to left. Which is the first value? That is 4. 8 power 0, 8 power 1, 8 power 2. We have a digits which is right side of the fraction or decimal point. That is, I have to give the weights of minus value. Minus 1, minus 2. Then we are going to perform the calculation and we are going to get the values as I shown here. Okay. So these are the weights. So 8 power 1, 8 power 0, 8 power minus 2, 8 power minus 1. These are the weights, and this 2, 3, 4, 5, 6. These are the digits that you can consider. Okay. Each digit has its own weight and it will be expressed in terms of 8. Then we are going to call that particular type of number system as what? Octal number system. So next we have what? Hexadecimal number system. So in hexadecimal number system, totally we are going to have, or it will going to consist of 16 digits. So we are going to have 16 digits in the hexadecimal number system, that is from 0 to 9 and A to F. So here we cannot take that as 10, 20, 12 like that. Okay. So it has to be between 0 to 9 and remaining value will be from A to F. So I will show you here the letter A and A to F will going to represent the decimal number which is equivalent to 10 to 15. Okay. So remember one thing, totally this hexadecimal number system consists of 16 digits. Okay. So that will be further classified into 0 to 9 and A to F. This hexadecimal number system totally consists of 16 digits. So that is from 0 to 9 and A to F. Okay. So 0 to 9 will be as it is. It can be combination of any number which is between 0 and 9. And here we have a to F. So remember one thing, A represents 10, B represents 11, C represents 12, and D represents 13, and E represents 14, and this F represents 15. Okay, so totally that will be from 0 to 15, but 0 to 9 we have, and also we have A to F, and this A is nothing but 10, B is 11, C is 12, D is 13, E is 14, and F is 15. So this is what you have to remember. So next, what is the base or radix of this particular number system? It is absolutely 16. Why? Because we have 16 different symbols in the hexadecimal number system, and the power will be represented with 16 itself, and it can be combination of 0 to 9 and A to F. A is 10 and F is 15. So we'll see the example here. Consider an hexadecimal number, that is 5AF dot D. So 5AF dot D. So can I take it as 5AGF, something like this? Why? Because we cannot take this Z, because this Z does not belong to the hexadecimal number system. We have to take a number which is between 0 to 9 and A to F. Okay, that must be the combination. So consider a hexadecimal number system 5AF dot D, which is the base is 16, and we are going to give its value, and weights will be given to the power of 16 itself. So now we'll see how we are going to represent this. So what is the first number that I have? 15 should be multiplied with 16 plus A into 16 plus F into 16 plus D into 16. So here I have to give the weights. So weight must be given from this side to this side, that is from right to left. Which is the first one? 16 power 0, 16 power 1 and 16 power 2. Okay, then 5 into 16 power 2 plus, what is the equivalent value of this A? Already I have given you. A is 10, B is 11, C is 12, D is 13, E is 14 and F is 15. So now you tell me what is the equivalent value of this A? That is 10 into 16 power 1 is 16 itself, then F is 15, any number with power 0 is absolutely 1, and D is 13 into, what is this value? Weight, that is minus 1 we are going to give. So 13 into 1 by 16 it will come. Okay, so when you get this, we are going to get the value 256, that must be multiplied by 5 plus, and this value, this weight. Okay, so then 15 into 1 is 15, and 13 into 1 by 16 will be 0.0625. Okay, this is how we are going to represent hexadecimal number system in its equivalent representation. Okay, these kind of questions can be asked for 1 marks question. So represent this number in the equivalent form. Okay, let me take one more example for this hexadecimal number system. 617.5B, which is base 16. Okay, can we consider this as a hexadecimal number system? Absolutely yes. Why? Because here I have a combination between 0 to 9 and I have A to F. So that is the numbers or a digits that you have to take when it comes to the hexadecimal number system. Then how we are going to represent it in the equivalent value? So it has the equivalent 6 into 16, because its what positional value will be raised to 16 itself. So that it has to be multiplied with 16 itself. So 1 into 16 plus 7 into 16 plus then 5 into 16, let me write in the next line, B into 16. Okay, so then 6 into 16, now we have to give the weights from this position 0, 1, 2 and up to that side minus 1, and this is minus 2. Okay, so 16 into 16 power 2 plus 1 into 16 power 1 plus 7 into 16 power 0 is absolutely 1 plus 5 into 1 by 16. Then B, what is the B value? That is 11, right? 11 into 16, that is 1 by 16 power to the 2. This is how we are going to represent any number with a particular type of number system. Okay, so now you have to analyze one thing: what are the types of positional number system that I have discussed, and what is its base or radix, what are the digits that we are going to use. Okay, so if you look into this tabular column, you will get to know that. So when it comes to the number system, that is positional number system, so totally we have 4 types. Which are those? Binary, octal, decimal and hexadecimal. So what is the base of binary? That is 2. Then what are the digits that I can use? It can be 0 or 1. So in the octal number system, its base or radix is 8 and it has a number between 0 to 7. That is 0, 1, 2, 3, 4, 5, 6 and 7. Then decimal number system, its base or radix is 10. We are going to represent its power or a value which is raised to 10. Then the numbers will be between 0 to 9. That is 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. Then we have hexadecimal number system and its base or radix is 16. Okay, so this is 16 and the numbers will be between 0 to 9 and A to F. Okay, so 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 will be as it is, and A is represented by 10, B is 11, C is 12 and this D is 13, E is 14 and F is 15. So this is what the number system. Types of number systems are non-positional and positional. In positional, decimal, binary, octal and we have hexadecimal. So along with its base or radix and total number of digits that we can represent and in which power it will going to be raised, everything you have to remember. I hope this is clear for all of you. So in my next session, we are going to represent or we are going to have a discussion regarding the conversions of a number system. So anyway, you know that computer understands only zeros and ones. That is nothing but binary number system. Okay, so computer does not understand decimal, octal or any hexadecimal. It has to be converted into binary. So that we are going to do in the next session. I hope you all understood with today's session. Let me meet you in the next session with a continuation of this chapter. Until that, keep learning, keep on growing. Thank you.